Hello everyone. In this video, I'll explain how to solve nth order linear differential equation. See, linear differential equation means the first condition is that power of y and its derivative must be equal to 1, or degree of y and its derivative should be equal to 1. And second condition is that y and its derivatives are not multiplied together. Y and its derivatives are not multiplied together. Okay. In such cases, we call the given linear differential equation as a linear differential equation. See, for example, suppose if you have dy by dx whole square plus 2y equal to 1. So, in this case, this equation is not linear. That is because the degree of or power of the first order derivative equal to 2. Okay, it should be equal to 1. Whereas y as well as the derivatives. So even if you have 2y cube here, in that case also the given equation is not a linear equation. In the second condition, and y and its derivatives, say for example y dash plus 2y double dash equal to 5. So in this case, look here, function dependent variable and its derivative are multiplied together. Or if you have y triple dash into y double dash plus 5y dash equal to 0 or 6. In this case here, two derivatives are multiplied together. So in all these cases, these equations are not linear. To say any equation as a linear differential equation, these are the main two conditions. Now here we are dealing with nth order linear differential equation. Nth order means the highest order derivative occurring in the differential equation is nth order. See, first order means there is only dy by dx term. Second order differential equation means the highest order derivative occurring in the differential equation is d square y by dx square. Third order, fourth order, like that. Now you have to write the standard form of nth order linear differential equation. Nth order linear differential equation. So the standard form is given as dny by dxn plus a1 dn minus 1y by dxn plus a2 dn minus 2y by dxn minus 2 plus so on up to an into y equal to phi of x. So this is the standard form of nth order linear differential equation. Here a1, a2, so on up to an, these are either constants or functions of x alone. Functions of x. Okay. So this is the standard form. Using operator, see, we know that d, capital D equal to d by dx. So d square equal to d square by dx square, and so on. So here it becomes dny plus a1 dn minus 1y plus a2 dm minus 2y plus so on up to an into y equal to phi of x. So when you take y common, you will get dn plus a1 dn minus 1 plus a2 dn minus 2 plus so on up to an into y is equal to, because every term y common, equal to phi of x. Now this can be treated as a function of the differential operator d into y equal to phi of x. So this is how we can write the standard form of nth order linear differential equation using the operator f of d into y equal to phi of x, where f of d is a function of that differential operator whose highest power is here n. Now there are two types of nth order linear differential equation. So the main thing is one with the constant coefficients and another is with variable coefficients. So constant coefficient means based on the coefficient, this is the category of nth order linear differential equation. Constant coefficients means a1, a2, a3, so on up to an. All these are constants. Okay, then we call that linear differential equation as constant nth order linear differential equation with the constant coefficient. Variable coefficient means these are functions of x. They are functions of x. You may have some terms may be constant, some other terms are functions of x. In that case, we call that differential equation as a differential equation with the variable coefficient. This is based on the coefficients of the given nth order linear differential equation. Because there are different methods to solve differential equations with constant coefficients and variable coefficients. Now, based on this function phi of x, there is one more category of differential equations. Two more types. One is with the homogeneous differential equation and non-homogeneous differential equation. Under nth order linear differential equations only, homogeneous means phi of x equal to 0. Non-homogeneous means phi of x not equal to 0. There is a function on the right hand side of the equation which is not equal to 0. There is some particular function that will be given. So in that case, the differential equation becomes nth order non-homogeneous linear differential equation. If this phi of x becomes equal to 0, then it is a homogeneous differential equation. These are the category of nth order linear differential equation. See, for example, d square y by dx square plus 2 into dy by dx plus 3y equal to 0. This is an example for second order, because highest order derivative is second order. Linear, because highest power of each derivative is 1 and highest power of y is also equal to 1. Second order linear differential equation with the constant coefficients. Because here 2, this is 3, here coefficient is 1. That's why it is called as with constant coefficient, and it is homogeneous also. This is homogeneous because the right hand side phi of x is equal to 0 here. Next, similarly, one more you can have like d square y by dx square. I am giving just general example, either it is solvable or not, that is secondary, just an example to understand differential equations. Now x into dy by dx plus 3y equal to some e to the power 3x. So in this case, this is a second order linear differential equation with the variable coefficients, and it is non-homogeneous also, because right hand side phi of x is e to the power 3x, which is not equal to 0, and here the coefficient of dy by dx is this is non-constant variable, hence it is called as a differential equation with variable coefficients and non-homogeneous. See, now geometrically, to understand what nth order linear differential equation is, means it represents some family of curves. Because its solution is a family of curves. Homogeneous means there is no forced factor there, means a particular factor if you include, then that changes the system. Whatever the system you have, based on that system, if you are observing the system, dynamic system, and you are getting the behavior of the system in terms of a differential equation, if there is no external factor, then you will have right hand side equal to 0, due to which you will get a homogeneous differential equation which represents a family of curves. Okay, non-homogeneous equations also represents family of curves. These are also representing family of curves, but with the forced curvature. There's some forced curvature. This is some normal curvature based on the given differential equation. What differential equation gives the family of curves, based on that you will have curvature accordingly. But here you will have some forced curvature that is due to the factor, existing factor, which is a non-zero factor here. It is perturbation of homogeneous solution. This is you have a homogeneous solution for this non-homogeneous differential equation also. Okay, but along with that there is some disturbance due to this forcing term, introducing that disturbance. This disturbance in the system is introduced by this new term, which is called as a forcing term there, and it changes the nature of this family of curves. So in that case you will have a different solution. Along with the homogeneous solution, there are other possible solutions also. Therefore, when you are solving nth order linear differential equation, you have two set of solution. One is complementary function, another is particular integral. Complementary function is the solution of homogeneous equation, and this is the solution of a non-homogeneous equation. Okay, then general solution, you have general solution gives you all possible solution of the given differential equation. You have to check, is it homogeneous or not. If it is homogeneous, it has only this complementary function as its solution, which is denoted as yc. If it is not homogeneous, then along with the complementary solution, it will have the particular integral also. So you will have to write it as yp, particular integral, because due to that new factor, this new factor introduces some disturbances in the earlier solution, due to which there will be forced curvature in the family of curves. Hence the solution changes. This could be one possible solution. Along with that, there is another possible solution. Then all possible solutions together, that is y equal to yc plus yp, is called as the general solution of the nth order linear differential equation. Now let us see how to find the solution of nth order linear differential equations with constant coefficients. You know that the coefficients are all constant. So in this case, what we have to do is, and here it should be homogeneous. First, let us find out solution of nth order linear differential equation with the constant coefficients, and that differential equation is homogeneous. What is the general form? F of d into y equal to 0. There will no phi of x term here, it is equal to 0. So you will have just solution as a complementary function. You have to find out the complementary function. Therefore, let us see how to find the complementary function of a homogeneous differential equation. So first step is you have to write f of m equal to 0. That is nothing but auxiliary equation of given differential equation. Then you have to find the roots of that auxiliary equation. After finding the roots of that auxiliary equation, you have to form its complementary function, write its complementary function based on three cases. If the roots are real and distinct, then the complementary function is given by, suppose you have an nth order linear differential equation, so auxiliary equation will be nth order polynomial, so due to which you will have n roots. So if suppose m1, m2, m3, so on up to mn, these are the n distinct roots of that auxiliary equation. In that case, complementary function is written as c1 e power m1x plus c2 e power m2x plus c3 e power m3x plus so on up to cn e power mnx. This is how to write the complementary function. Roots are real and distinct. Next case is if roots are real but repeated, real and repeated. So in that case, let us see how to write the complementary function. Suppose I will take second order linear differential equation. Nth order, instead of nth order, n equal to 2, second order linear differential equation. So how many roots? It has 2 roots. Suppose both the roots are repeated, real and repeated. Suppose m is a root, it is repeated 2 times. So in that case, how to write the complementary function? See, c1 plus c2 into x into e to the power mx. So if there is a repetition, you have to add this factor multiplied by e power mx. Suppose if you have third order linear differential equation, and if that root m is repeated 3 times, so in that case yc equal to c1 plus c2x plus c3x square into e power mx, like this. Okay, based on the repetitions. So here you should have these 3 terms with the power of x as n minus 1. So nth order linear differential equation if you have, then if it has m root m which is repeated n times, then c1 plus c2x plus c3x square plus so on up to cn x power n minus 1 into e to the power mx. This is how to write the complementary function. Next, if you have roots which are complex roots, then in that case, suppose you take second order linear differential equation. So in that case, if you have second order linear differential equation, m root alpha plus I beta, and you know that complex roots always occur in conjugate pairs, then alpha minus I beta is also a root. So in this case, you have to write the complementary function as yc equal to e to the power alpha x into, that is common, c1 cos beta x plus c2 sin beta x. This is how to write the complementary function. This is second order linear differential equation. Next, suppose if you have a fourth order linear differential equation with the complex roots, that is m1 equal to alpha plus or minus I beta and m2 equal to p plus or minus I into q, two different, totally 4 here. Yc equal to e to the power alpha x into c1 cos beta x plus c2 sin beta x plus e to the power px into c3 cos qx plus c4 sin qx. Now if you have these complex repeated roots, suppose you have alpha plus or minus I beta repeated roots twice, if you consider it as 2 times repeated, then in that case complementary function is written as e to the power alpha x, then c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x. This is how to write the complementary function. If you have complex roots which are repeated, suppose if you have complex roots repeated n times, in that case you have to write the complementary function as e power alpha x. This is always there, c1 plus c2x plus so on up to cn x power n minus 1 into cos beta x, then plus c1 dash you can take because rest all taken before, plus c2 dash x so on up to cn dash x power n minus, this is x square, into sin beta x. This is how to write the complementary function when you have complex repeated roots and it is repeated n times. So remember it like this: when you have complex root for second order linear differential equation, you write, remember it like this: e power alpha x plus into c1 into cos beta x plus c2 into sin beta x. That imaginary part is to the trigonometric functions and the real part is to the exponential function. So this is how to solve the auxiliary equation and write the complementary function. Let us illustrate this with the examples. See the first problem. Solve d cube y by dx cube minus 2d square y by dx square plus 4 into dy by dx minus 8y equal to 0. This is third order because highest order derivative is third order. Linear because every derivative has highest power equal to 1 and no derivative and dependent variables are multiplied together. Ordinary differential equation with the constant coefficients and homogeneous because right hand side is 0. Therefore, while finding the solution, it is enough if you find the complementary function. That itself is the only possible solution of this homogeneous differential equation. So you can write it in the operator form d cube y minus 2d square y. That simplifies your work. Plus 4 into dy minus 8y equal to 0. That is d cube minus 2d square plus 4d minus 8 into y equal to 0. This is of the form f of d into y equal to 0. Now what is the first step in solution of homogeneous equation? Find auxiliary equation. Auxiliary equation is given by f of m equal to 0. Here replace, why you leave it, just you consider this, replace d by m. M cube minus 2m square plus 4m minus 8 equal to 0. How to simplify this? Here it is easy, no need to go with the synthetic division method. Otherwise, to solve cubic equation, you have synthetic division method. See, take m square common, m minus 2 plus 4 common, m minus 2 equal to 0. Then m minus 2 common, m square plus 4 equal to 0. Now let us find the roots of this auxiliary equation. Roots are m equal to 2 and here m square equal to minus 4, m square equal to square root of minus 4, m equal to, this is m equal to square root of minus 4, which is nothing but plus or minus here. This is square root of 4 is 2, square root of minus 1 is I. So plus or minus 2i. So it has real as well as complex roots, because any polynomial of odd degree will always have a one real root. That is must, because whenever you have complex root, they always occur in conjugate pairs. So if one complex root exists, another must be complex root. So two roots done, then another one more must be real. If it is complex, one more root should exist, but that is not possible. You know that cubic equation have maximum 3 roots. So you have one real root, one complex, two complex roots now. So how to write the complementary function? So solution, complementary function, which is equal to, one real root means c1 e power 2x. It is real and distinct, plus here these are complex roots. So c2 into, so e to the power, what is the real part? There is no real part. It is 0 plus or minus 2i, correct? No. So e to the power 0x into c1 cos beta is, the imaginary part is 2x plus, here you can take c2 because c1 already taken, c3 sin 2x. So if you simplify, you will get c1 e power 2x plus c2 cos 2x plus c3 sin 2x. This is the solution of the given homogeneous differential equation, and this solution represents family of curves. So YC, this itself is the general solution, because homogeneous differential equation has only the complementary function as its solution. See the next question. D power 4 minus 5d square plus 4 into y equal to 0. Already in the operator form, f of d into y equal to 0. This is fourth order linear differential equation with constant coefficients, and it is homogeneous. So you need to get the auxiliary equation is f of m equal to 0. Replace d by m power 4 minus 5m square plus 4 equal to 0. I have to simplify this. So you can solve it like this also. When you multiply, you should get 4m power 4. This is 4, first and last, 4m power 4, and when you add, you have to get minus 5m square. So the possibilities are 4m square, m square, and with a minus. So minus of minus plus 4m power 4. When you multiply, you will get this. When you add, you will get minus 5m square. So m power 4 minus 4m square minus m square plus 4 equal to 0. Factorizing technique. That's it. M square minus 1 into m square minus 4. Here also m square minus 4. So you will get m square minus 4 into m square minus 1 equal to 0. So this gives you m equal to plus or minus 1, m equal to plus or minus 2. Okay, therefore totally there are 4 roots. All 4 roots are distinct. One is 1, minus 1, 2, minus 2. They are real and distinct. So how to write the complementary function? Yc equal to complementary function is c1 e power x plus c2 e power minus x plus c3 e power 2x plus c4 e power minus 2x. This is the solution of the given differential equation. See the next question. Solve this equation. Using operator, we can write this as d power 4 plus 8d square plus 16 into y equal to 0. So it is homogeneous linear differential equation with constant coefficient. So f of d into y equal to 0. So write the auxiliary equation is f of m equal to 0. So m power 4 plus 8m square plus 16 equal to 0. So this can be written as m square plus 4 whole square equal to 0. When you apply the formula, you will get a plus b whole square, m power 4 plus 4 2 is 8m square plus 4 square is 16. So this is m square plus 4 equal to 0. So m equal to square root of minus 4 you will get, that is plus or minus 2i and plus or minus 2i, because it is a biquadratic equation, hence it should have 4 roots. So roots are repeated here because m square plus 4 equal to 0 and more factor m square plus 4 equal to 0. It is a whole square 2 times. So it is m equal to plus 2i minus 2i, because complex roots occur in conjugate pairs. For this factor again plus 2i minus 2i. So now the roots are complex, but they are along with that repeated. So how to write the complementary function? Yc equal to, for the repeated roots, you have to write c1 plus c2x into cos of 2x plus c3 plus c4x into sine of 2x. E to the power you don't want here because it is 0 plus 2i. Real part is 0. E power 0x is, it is 0. Then you have c1 cos of beta x plus c2 sine of beta x. As it is repeated, 2i positive root is repeated twice, negative root is repeated twice. So c1 plus c2x cos 2x plus c3 plus c4x into sine 2x. This is how to write the complementary function. Now see the fourth question. Here this is f of d into y equal to 0. So auxiliary equation is f of m equal to 0. You will get m power 5 minus m power 4 minus m plus 1 equal to 0. Why you leave it? Why you need not consider? Just you have to consider f of m equal to 0. So now you have to simplify this. When you take m power 4 common, m minus 1 minus 1 common, m minus 1 equal to 0 from these two factors here. So you will get m minus 1 again common, m power 4 minus 1 equal to 0. So m equal to 1, then this can be written as m square whole square minus 1 square equal to 0, which is m square plus 1 into m square minus 1 equal to 0. So you will get here m equal to plus 1 as well as minus 1. These are the two roots, because m square equal to 1, m equal to plus or minus 1. And here you will get m square equal to minus 1, which is m equal to square root of minus 1 plus or minus. So m equal to plus or minus I. So totally how many roots? M equal to 1, 1, minus 1, I minus I. Total 5 roots. It is a fifth order polynomial. Auxiliary equation is a polynomial of degree 5. So 1 is repeated 2 times. This is repeated. And minus 1 is real. And I minus I, these are complex roots. So you have to write the complementary function accordingly. So c equal to c1, distinct roots write first, e to the power minus x. Okay, distinct real plus, now 1 is repeated, c2 plus c3x into e to the power x. Okay, plus I and minus I complex. So it is having real part, it is equal to 0. Okay, therefore e to the power 0x into c4 cos I, here beta equal to 1, c4 cos x plus c5 sin x. So after simplifying, will c1 e power minus x plus c2 plus c3x into e power x plus c4 cos x plus c5 sin x. This is the required solution. The next question. Solve d power 4 plus 64 into y equal to 0. This is of the form f of d into y equal to 0. You have to get auxiliary equation is f of m equal to 0, which is m power 4 plus 64 equal to 0. Now this can be written as m square whole square plus 8 square, which is equal to 0. Now here we have to make use of the formulas. A plus b whole square equal to a square plus b square plus 2ab. So but that is directly not available here. Just we have a square plus b square. So a square plus b square equal to a plus b whole square minus 2ab. So therefore, as per this formula, it is m square plus 8 whole square minus 2 into m square into 8 equal to 0, where a is here, a is m square and b is 8. So that this is equal to m square plus 8 whole square. This is minus, this is 16m square you will get. 16m square can be written as 4m whole square equal to 0. Now here you can apply the formula a square minus b square, a plus b into a minus b. So this is simplification technique. M square plus 8 plus 4m into m square plus 8 minus 4m equal to 0. Now you have to solve these two factors. One is m square plus 4m plus 8 equal to 0 and m square minus 4m plus 8 equal to 0. So you can check in both cases what is discriminant. B square minus 4ac delta equal to b is 4, 16 minus 32, 8, 4 is 32, which is less than 0. Therefore it has complex root. Directly you go with the formula minus b plus or minus square root of b square minus 4ac by 2a. This is the formula. So m equal to minus 4 plus or minus 4 square is 16 minus this is 32 divided by 2 into a is 1. So after simplification we will get here minus 4 plus or minus, we get minus 4 plus or minus, this is square root of minus 16 by 2. So this is equal to minus 4 plus or minus, square root of 16 is 4, square root of minus 1 is I by 2. This is equal to minus 2 plus or minus 2i. Similarly, the roots of this factor minus of minus 4, which is plus 4. Here b equal to minus 4 now, plus or minus square root of 16 minus, this is same, 4ac is 32 divided by 2 into 1. So 4 plus or minus square root of minus 16 by 2, this is equal to 4 plus or minus 4 into I by 2, which is 2 plus or minus 2i. Therefore, it has all complex roots now. So, complex roots are minus 2 plus 2i and minus 2 minus 2i, then 2 plus 2i and 2 minus 2i. So, for these two roots, the complex solution how to write that you know, and for these two roots together. No repeated roots, all the roots are distinct. So, the solution you are writing it pairwise only for complex roots. So, complementary function equal to C here e to the power alpha is minus 2, beta is 2. So, e to the power minus 2x into c1 cos 2x plus c2 sin 2x. Okay, for all, both the roots together, we are writing this single solution. Don't write it separately because cos and sin term, two different terms are there. So that covers these two conjugate roots. Next, plus, here e to the power alpha is plus 2 now. E to the power 2x into, here c3 into cos 2x. Beta is same here, 2 plus c4 into sin 2x. So this is how we write the complementary function for this differential equation. See last one, this is sixth one, solve. This is the given differential equation. Its auxiliary equation is m square into m square plus 2m whole square into m square plus 2m plus 2 whole cube, which is equal to 0. So m square equal to 0 means m equal to 0 repeated twice because here you have square. So this is one of the root. M square plus 2m equal to whole square equal to 0. So m common, m plus 2 whole square equal to 0. So this implies m square equal to 0, m plus 2 whole square equal to 0. This gives you m equal to 0 repeated twice, and here equal to m equal to minus 2, that is repeated twice. Next is this m square, this factor m square plus 2m plus 2 equal to 0. Here you will get here discriminant b square minus 4ac. So 4 minus 8 less than 0. So complex root, directly apply the formula. Minus 2 plus or minus square root of b is 2. 4 minus 4ac is 8 divided by 2a is 1. 2 into 1. So minus 2 plus or minus, this is square root of minus 4, which is 2 into I by 2. This is equal to minus 1 plus or minus I. So these are the roots now, and it is a whole cube here. This is whole cube equal to 0. That means this root is repeated 3 times. Minus 1 plus or minus I, minus 1 plus or minus I, minus 1 plus or minus I. So totally how many roots now? 2 plus 2, 4, 5, 6, and here it is 3 times repeated. So 12 roots you have. See here degree is also 12. 3 2s are 6, then 2 2s are 4, 10, and 2. Total 12 roots you have. So these are complex roots, always occur in conjugate pairs. So though it is 3 times repeated, you have to write it plus or minus. So totally there are 6 roots. So this is root whole cube you have, so it is repeated 3 times. Therefore now complementary function, write it carefully, 0 repeated 4 times. So c1 plus c2x plus c3x square plus c4x cube, 4 terms you got, into e to the power 0x, which is nothing but 1, plus next minus 2 repeated 2 times, c5x, next c5 plus c6x into e power minus 2x. Okay, next plus here, this is repeated, minus 1 plus or minus I, repeated here it is 3 times. Therefore you will have e to the power minus x, alpha is minus 1, beta is 1. Okay, into within this bracket you have to write that repetitions. It is repeated 3 times, therefore c7 plus c8x plus c9x square. Okay, into cos x plus similarly c10 plus c11x plus c12x square into sin x. So this gives you the complementary function or solution of the given differential equation. So be careful here, these are complex repeated roots. So first write that e term, then you have to write the repetition factors, factor for the repetition multiplied with the cos function, and here it is multiplied with the sin function. Give the constant names like this, continuous name, so there is no confusion about constants. So this is how we solve an nth order linear homogeneous differential equations. In the next video, I'll explain how to find the solution of non-homogeneous equations. That there you have an extra particular integral.